Hello everyone. In this video, we're going to be solving an interesting homemade functional equation. I don't think I've seen this problem anywhere else, so probably came up with the idea. I could be wrong though. If you find this problem anywhere, please let me know. Anyway, so the problem is we have f of x is given as f of x plus x, and we're supposed to find f of 0. Is the solution unique? How many methods can we use? How can we solve this problem? Those are some of the things that I want you to think about as we go into the solution. I'll be presenting two methods, and let's start with the first one. So for my first method, I'm going to go ahead and replace x with 0, okay? That kind of makes sense, doesn't it? Because we're looking for f of 0, and f of 0, if you replace x with 0, you're going to get that somehow, right? So from here we get f of 0 is equal to f of 0 plus 0, right? Great. So now we don't know what f of 0 is, but we know that this is 0. So let's go ahead and set f of 0 equal to something. How about setting f of 0 equal to a? So if we can solve for a, then that will be the answer, right? So let's go ahead and replace f of 0 with a, so that gives us f of a equals a. Awesome, great. Now, let's go ahead and save this result. We're going to use it later. Now, because we got f of a as a result, right, it will make sense, again, to replace x with a. So first step was replacing x with 0. The second step would be replacing x with a so that we can get f of a. Well, we're also going to get f of a, which we can hopefully fix. So now let's go ahead and set x equal to a. The equation gives us f of a equals f of a plus a. Now this is kind of interesting, isn't it? Because now this gives us f of a again, so this is equal to a by the first equation, right? And then this means, and of course, f of a is equal to a. So from here we get f of a equals 2a. All right, what is that supposed to mean, right? Well, previously we found that f of a is equal to a. Now we're saying that f of a is equal to 2a. How is that possible? Well, it's only possible if these two things are equal. In other words, because they're both equal to f of a, this means 2a is equal to a. And this is kind of weird because if you cancel out the a's, you end up with 2 equals 1, which doesn't make sense at all, right? Obviously, this is not true. So you shouldn't be canceling. And the reason is simple, because a is 0. And you can't divide by 0. You're not supposed to do, right? At least if you don't want to make it undefined. What should we do instead? Instead of dividing, you should subtract. And that gives you a equals 0. Easy, right? And what was I looking for? I was looking for f of 0, and f of 0 happens to be a. So we got the answer. This means f of 0 is equal to 0. Wow, really? Okay, now I want you to think about this. What would happen, or what would you do if they asked for f of 1? Would you be able to find it? Now, the second method that we're going to use is actually going to give you a different perspective, because that'll basically assume the type of function that we're looking for. We don't know what type of function we're dealing with, but how many different types of functions do you know, right? I mean, there's a finite number. Obviously, you can define infinitely many functions for which this is probably true. But here's what we're going to look at. So the question will be, can f of x be linear? Can it be quadratic? Can it be exponential? Is it a polynomial? Is it a trigonometric function? You see, all of these possibilities we're going to try to explore. For example, if f of x is a polynomial, or let's start with the exponential. If f of x is an exponential, if you don't know the base, it could be e to the power x multiplied by something, or it could be something like a to the power x, where a doesn't have to be e. And this kind of represents the same, because you can basically find an a value for which a to the power x is equal to k times e to the power x. And if you're looking for what the value of k is going to be, you can kind of use logarithms and go from there. But I'm not going to spend too much time on this, but just saying we're looking for a solution in this form, a to the power x. Okay, let's go ahead and plug it in. If f of x is a to the x, f of x is just going to be f of a to the power x. So what does f do? It does a to the power the input, so it's going to be a to the power x, right? Great. And we want this to equal f of x plus x, which is a to the power x plus x. Now think about this. Can you solve an equation like this? Probably not. You could try this. You can set a to the power x equal to y. Then you get something like a to the y equals y plus x. The problem is you have two variables. You can try natural logs, so on and so forth. But again, that will be very, very problematic. But here's the thing. Look at some of the particular values. So here's the problem. Of course, depending on the value of a, but if a is greater than 1, you're going to run into this problem. This is going to grow faster. So there's no way these two can be equal. But let's just test some values. For example, what happens if a is equal to 1, right? If a is equal to 1, you get something like 1 to the power x, which is 1. And then 1 plus x. From here, x equals 0. But wait a minute. We want this to be true for all values of x. We don't want just a particular value. So this is not going to work. What about a different value? Maybe a can be something like 1/2, possibly, right? So it's going to be like 1/2 to the power 1/2 to the power x equals 1/2 to the power x plus x. So this is problematic. And chances are you're not going to find any real solutions. By the way, you can test this out by graphing both of these functions. And in Desmos, if you use a parameter like a, you can actually set, I forgot what it's called. Is that a slider? Yeah, you can kind of play it or use different values of a and see how this plays out. So you can actually graph these two as two separate functions and then check their intersection points. Of course, it's going to give you a slider as soon as you enter a. And then you can kind of give a range and so on and so forth. A lot of things to explore here, pretty interesting stuff. But I don't think there are any solutions. I'm just guessing, by the way, but this doesn't really give us anything helpful. So now let's go ahead and take a look at another case. Maybe something trigonometric, right? Can f of x be something like cosine of x? It's very unlikely because this is going to complicate things. Suppose f of x is something like cosine of x. And then you're going to get cosine of x equals cosine of x plus x. Again, these are non-standard transcendental equations. So you would need numerical methods or graphing to be able to solve them. Of course, you can also use inequalities to prove that there are no solutions, so on and so forth. But that's beyond the scope of this channel. But I'm just trying to show you that these are not good cases and we can really deduce, but I'm guessing that won't be a good solution this way. So let's look at an easier case. For example, can f of x be a polynomial? And chances are it can be, because when you compose f with itself, you're going to get another polynomial, and a polynomial can equal another polynomial, which is very likely, right? But with the case of trigonometric or exponential, things get too complicated too quickly. So maybe assume something like a sub n x to the n, a sub n minus 1 x to the n minus 1. But again, this is pretty complicated. Here's the problem. If you compose f with f, like f of f, the degree will double, right? Because when you replace, as soon as you replace x with something like this, and then of course there's more to it, right? And raise it to the nth power, you're basically going to be raising n to the nth power. That's going to give you n squared. Did I say double? I meant n squared. So think about it this way. Can f of x be quadratic? Let's think of it this way. It's a lot easier to think of quadratics and linear functions and so on and so forth. Now, f of x is just going to be a times ax squared plus bx plus c to the second power plus b times ax squared plus bx plus c, just replacing x with f of x plus c, right? Now, notice that this is going to give you a quartic equation. There's no way that can equal f of x plus x, right? Oops, that's not where I'm supposed to write it. There's no way this is going to equal f of x plus x, so quadratic is not going to work. Why? Because you square the degree, and you don't get the same number. So we have to think of it this way. Is there a number whose square equals itself? Wait a minute. Are you talking about this? N squared equals n? Yeah, this equation has two solutions. We can kind of write it like this. And from here, we get n equals 0 or n equals 1. But what does n equals 0 mean? N equals 0 means our polynomial is constant. So can f of x equals c be a solution? Let's check it out, right? So remember, our original problem was this. Of course, I'm not saying this implies that by any means, right? If f of x is a constant, this is going to be a constant, and this is going to be a constant, but then you're going to have x equals 0. Again, this is not true for all values of x. If it were, then the x's would totally cancel out and we would get a value for c, or it would just be c equals c, which would mean that if we didn't have the x fact, constant would be a solution. But it's not in this case. So the only option we have left is, can f of x be a linear function? And the answer is possibly. So let's go ahead and write it as ax plus b. And then use our equation again, right? The only way to test if our solution is good, let's go ahead and plug it in. Now, this is going to be like f of ax plus b equals ax plus b plus x. And then from here, if you plug in ax plus b, this is going to be a times ax plus b plus b equals, now we can put these two together. A plus 1 is the coefficient of x plus b. Now these two polynomials can equal because they're both linear if the corresponding parts are equal. And what that means is, actually this is really cool. This brings us to a very important concept. Can you smell it or can you see it? Hopefully you can. This basically tells us two things. First, a squared must equal a plus 1, which is cool. We're going to look at it next. And then this equals that. But this equals that means that b cancels out, and this means a equals 0 or b equals 0. But we know that a does not equal 0 from the other equation, and there's an and here, okay? Because these two polynomials have to be equivalent for all values of x over the domain, which is the set of real numbers. So a cannot be 0. The only option is then b equals 0, which means we have a very simple linear function like f of x equals ax. Why didn't I assume that initially? Well, I kind of knew that, but I wanted to show you there shouldn't be a b there. But you had to see it, right? Okay. Now, what are we going to do with this? This is the coolest part, because if you solve this equation using the quadratic formula, negative b, wait, I forgot to put everything on the same side first. I got too excited because this is really cool. Now to solve it, we're going to use negative b plus minus the square root of b squared minus 4ac, which is 4 divided by 2a. And this gives us, ta-da-da-da, are you ready? Golden ratio, yay. Awesome, right? Don't you love that? Now, those are the values of a. So does that mean there are two solutions? Yes. So I'm answering that question. Is the solution unique? No. There are two solutions. And remember, we assumed that the solution is going to be in the form, or we found that solution can be in the form ax, and a are those values. So f of x is equal to 1 plus root 5 over 2 times x, or f of x can be 1 minus root 5 over 2 times x. In both cases, because we're looking for f of 0 would be 0. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath and Shorts channel and aplusbi. And bye-bye.